A man in Ontario spits into a tube, mails it away, and 6 weeks later opens an email that rewrites his sense of who he is. His last name is Fraser. He always assumed it meant something, a plaid, a crest, maybe a castle he'd never visited. What the email tells him is stranger than that. His Y-chromosome, the sliver of DNA passed from father to son, almost unchanged for centuries, carries a genetic signature that shows up again and again in men named Fraser, scattered across 3 continents. Men he has never met, men whose grandfathers left Scotland during the clearances, whose great-great-grandfathers may have stood on the same hillside in Inverness-shire. He is not imagining a connection. The DNA is showing him one. But here's the question that this video is actually built around. Does that signature prove he belongs to Clan Fraser? Or is it proving something else? Something quieter, older, and in some ways more interesting than the marketing on a DNA testing kit will ever tell you? 13 surnames keep surfacing in this story. MacDonald, Campbell, Stewart, Bruce, Wallace, Fraser, Gordon, MacLeod, Douglas, Robertson, Murray, Ross, Mackenzie. If your family carries one of these names, geneticists and genealogists have spent the last 2 decades quietly testing, comparing, and mapping the men who carry them. And what they found complicates the tidy story of clan DNA that gets sold in 15-second ads. Stay with this one, because the real answer sits underneath the myth, not on top of it. To understand what any of this means, you need to understand the tool doing the talking, the Y-chromosome. Every man carries one, inherited from his father, who inherited it from his father, in an unbroken chain stretching back generations. Unlike most of your DNA, which shuffles and mixes every generation like a deck of cards, the Y-chromosome mostly just copies itself forward. Small mutations do creep in over time. Tiny, harmless changes in the genetic code. And those mutations become markers. If 2 men share the same string of markers, it means they share a common male line ancestor, sometimes recently, sometimes centuries back. Here's the everyday version. Imagine a family recipe passed down only from father to son, copied by hand each generation. Most copies stay nearly identical, but once in a while a scribe makes a small, harmless slip. A word swapped, a comma moved. If you found 2 copies of that recipe today with the exact same slip in the exact same place, you'd know they both came from the same handwritten original, not from 2 unrelated kitchens. That's a genetic marker. It's not proof of a title or a tartan. It's proof of a shared paper trail, encoded in cells instead of ink. Genealogists realized decades ago that surnames in patrilineal cultures, names passed from father to son, the way Fraser or Campbell were, travel down the same line as the Y-chromosome. In theory, that means the surname and the DNA marker should move together through history. In practice, they mostly do, but not perfectly. And that gap between theory and practice is where this story gets interesting. There's a second layer to how these markers get grouped, and it matters for understanding what a result actually means. Beyond the individual mutations, geneticists sort Y-chromosomes into broader family trees called haplogroups, enormous branches representing tens of thousands of years of human migration. Being told you belong to haplogroup R1b, for instance, connects you to a lineage carried by a huge share of men. Across Western Europe, it says almost nothing about Scotland specifically. The surname-level detail, the fine mutations that separate one Highland lineage from another within that same broad haplogroup, is where the actually useful, clan-relevant information lives. A lot of the confusion around clan DNA comes from people mixing up these 2 scales. A haplogroup shared with millions of unrelated men, and a fine genetic signature shared with a few hundred men who likely descend from the same medieval family. One is a continent-wide category. The other is closer to a fingerprint. Starting in the early 2000s, several surname-based DNA projects began recruiting men with matching last names and comparing their Y-chromosome results at that finer level. The logic was simple. If a surname originated with one man in medieval Scotland and it passed faithfully from father to son for 600, 700, 800 years, then most living men with that surname today should share a detectable genetic signature. For some names, that is almost exactly what turned up. Take the MacDonalds. Historically, the MacDonald name descends from Somerled, a 12th century warlord whose descendants became the Lords of the Isles, ruling much of Scotland's western seaboard for centuries. Surname DNA projects testing men named MacDonald, along with related names like MacDougall and McAllister, found clusters of men sharing closely related Y-chromosome signatures, a pattern consistent with descent from a small number of medieval founders. It's not a single unbroken line back to one legendary chieftain. It's evidence of concentrated shared ancestry, which is its own kind of remarkable. Campbell tells a similar but messier story. The Campbells rose from a regional family in Argyll to become one of the most powerful clans in Scottish history, largely through political marriage and royal favour rather than pure bloodline expansion. When you test men named Campbell today, you find several distinct genetic clusters rather than one dominant signature. That's not a failure of the science. That's the DNA quietly confirming something historians already suspected. Campbell was never just one family. It was a name that absorbed allies, tenants and dependents who took on the surname of the clan that protected them. That detail matters more than it sounds like it does, so hold on to it. Now, consider Stuart. Few names in Scottish history carry more weight. It's the name of the royal house that eventually sat on the thrones of both Scotland and England. But Stuart originally wasn't a bloodline name at all. It was a job title. A steward managed a lord's estate, and over generations, the office became a surname, adopted by the men who held it, and informally, by people around them. DNA testing of men named Stuart today reveals exactly what you'd expect from an occupational name. Multiple unrelated genetic lines, all wearing the same label. If you carry the name Stuart, your DNA test is far more likely to tell you about a job your ancestor once held than about a single royal bloodline. That single fact quietly dismantles a huge share of the "you're descended from Scottish kings" marketing you've probably seen online. Bruce and Wallace occupy a different corner of this story. Names carried by two of the most consequential men in Scottish history, Robert the Bruce and William Wallace, both central to the wars of Scottish independence in the late 13th and early 14th centuries. Modern men named Bruce or Wallace sometimes hope their DNA will trace directly back to those two figures specifically. The honest answer from every credible surname project is the same. DNA can show that you share a common ancestor with other Bruces or other Wallaces from centuries ago. It cannot single out one specific historical individual from among many possible common ancestors, because the genetic markers don't come stamped with names and dates. The link to history is real, and the precision people want from it usually isn't there. Fraser, Gordon, and Mackenzie all show a pattern researchers describe as regional clustering. Men with these surnames from the same historical clan territories in the Highlands tend to share closer genetic signatures with each other than with men bearing the same surname, whose families originated elsewhere. That regional clustering is one of the strongest pieces of evidence that clan surnames really did carry meaningful shared ancestry for a significant number of families, especially in areas that stayed relatively isolated for centuries. MacLeod adds a twist that surprised even the genealogists running the projects. Y-DNA testing of MacLeod men has turned up a genetic signature associated with Norse ancestry in a notable share of participants, a finding that lines up with the clan's own oral traditions, which trace their origin to Liad, said to be a son of a Norse Gaelic king of the Isles. In this case, the folklore and the DNA are telling a strikingly similar story, which almost never happens as cleanly as it did here. Douglas, Robertson, Murray, and Ross round out the 13, and together they illustrate the same core lesson from slightly different angles. Douglas produces several distinct clusters, consistent with a name that spread through both bloodline and feudal allegiance across the borders and beyond. Douglas chiefs became so powerful in medieval Scotland that they were, for a period, genuine rivals to the crown itself, which meant the name absorbed tenants, allies, and dependents on a scale few other lowland families ever matched. Robertson and Murray showed tighter regional clustering tied to their historical territories in Atholl in the north, consistent with clans, that held onto a more compact, defensible heartland for longer stretches of time, rather than expanding rapidly through conquest or marriage. Ross shows a mix, some clear clan line clustering centered on the traditional Ross lands around the Cromarty Firth, and a meaningful number of men whose genetic signatures don't match the dominant cluster at all. A pattern researchers link to the clan's long history of absorbing smaller neighboring families during centuries of shifting Highland alliances. Mackenzie deserves one more moment on its own, because its story shows how a name can expand almost entirely through politics rather than blood. Clan Mackenzie grew from a relatively modest Highland family into one of the most powerful clans in the north of Scotland, largely by backing the right side in the right conflicts, gaining land and a royal favour at the expense of rival clans. As Mackenzie territory grew, so did the number of families who fell under Mackenzie protection and eventually took the Mackenzie name, which is exactly why modern DNA testing finds a strong central cluster of closely related men, surrounded by a wider halo of Mackenzies whose genetic ancestry traces somewhere else entirely. The name spread faster than the bloodline ever could, and the DNA data quietly preserves the evidence of that gap 800 years later. Zoom out from any single name, and a bigger picture starts to form. Across all 13 surnames, the strongest, tightest genetic clusters tend to belong to clans that stayed geographically isolated the longest. Highland and Island clans, whose territory was hard to reach and harder to leave. The messiest, most genetically diverse clusters tend to belong to clans that grew through political power, feudal office, or proximity to major trade and travel routes. where outsiders had more chances to marry in, settle down, and eventually take the local name. In other words, the DNA isn't just confirming who's related to whom, it's mapping, marker by marker, which parts of Scotland stayed closed off and which parts stayed open, a kind of genetic shadow of the country's own geography and politics. That last detail, the men who don't match, is not a footnote. It's the whole point of this video. Before we get there, it's worth pausing on why the mismatch rate is so consistent across almost every surname project ever run, Scottish or otherwise. Genealogists who study this across hundreds of family lines have converged on a rough working expectation. Over many centuries and many generations, some noticeable minority of men in any surname line will turn out to carry a different genetic signature than the expected one for their name. That is not a flaw in the testing. It is what you'd predict from ordinary human history repeated over roughly 20 or 30 generations. Even a small, steady rate of unrecorded adoptions, remarriages, or informal name changes per generation compounds dramatically over 800 years. The surprising thing, if anything, is that the dominant clusters remain as strong and identifiable as they do. It also helps to understand how a name could spread through a clan without any blood relationship at all, because the mechanism is specific to how Highland society actually worked. A sept was a family or group formally attached to a larger clan, sometimes through marriage, sometimes through simple geography, and sometimes because a smaller family sought the protection of a stronger. Neighboring chief and adopted his name and allegiance in return for safety during centuries of cattle raids, blood feuds, and shifting territorial control. Sept status wasn't a metaphor. It carried real legal and military weight. Sept members fought under the clan banner, owed loyalty to the chief, and were counted among his people, whether or not a single drop of his blood ran in their veins. Multiply that arrangement across a few dozen septs per major clan over several centuries, and you get exactly the pattern the DNA shows today. A strong core cluster surrounded by a wider ring of genetically unrelated men carrying the same proud name. Every single one of these surname projects, across all 13 names, uncovers a percentage of men who carry the surname but do not share the genetic signature associated with it. Genealogists have a name for this, a non-paternity event, though the phrase covers far more than infidelity. It includes adoption. It includes a stepfather's name taken by a child. It includes an illegitimate birth quietly absorbed into a family generations ago. It includes a clan tenant formally granted the surname of the chief who protected him, with no blood relationship at all, which, remember, was standard practice under the old Highland clan system, where clan itself comes from the Gaelic clan, meaning children or family, but functioned in practice more like a political and military alliance than a strict bloodline. That's the moment this story has been building toward. The word clan was never purely genetic to begin with. A clan was a following, a chief, his blood relatives, his tenants, his allies, and anyone who took shelter under his name during centuries of raiding, feuding, and shifting alliances across the Highlands. People joined clans. People were absorbed into clans through marriage, protection, or simple survival. DNA cannot see any of that social history. It can only see biological descent through one narrow male line. So when a DNA testing company tells you your surname reveals your true clan, it is selling you half the story and calling it the whole thing. The genetic data is real. The surname projects are genuine, peer-reviewed genealogical research, not gimmicks. But true clan implies a single, pure bloodline waiting to be uncovered. And the honest results across all 13 of these surnames show something more layered. Dense clusters of shared ancestry sitting right alongside branches added by marriage, adoption, protection, and the ordinary messiness of human history. Here's what the evidence actually supports and where it stops. Established. Y-chromosome markers reliably show shared paternal line ancestry between men, and surname projects have documented clear, repeatable clustering patterns for names like MacDonald, Fraser, Mackenzie, and MacLeod. Strongly supported. Several of these clusters align with documented clan territories and, in MacLeod's case, with the clan's own origin traditions. Plausible but not settled. Exactly which centuries certain sept lines joined which clans, since written Highland records only go back so far, and much of that history survives in oral tradition rather than paper. Disputed or overstated. Any claim that a DNA test can identify descent from one specific historical figure, such as Robert the Bruce or William Wallace personally, rather than from an ancestor shared among many descendants. Unknown and probably unknowable. Exactly how many living men under a given surname joined that lineage through adoption, sept membership, or unrecorded events rather than direct blood descent. The further back in time, the murkier that number becomes. It's also worth being honest about what a modern consumer DNA test can and cannot tell you on its own. A standard autosomal test, the kind most people buy, mixes together ancestry from all your family lines and reports broad regional percentages. It was never built to isolate one specific surname lineage. Identifying a clan-relevant genetic signature specifically requires a Y-chromosome test taken by a man, compared against a database of other men who share his surname and have already been tested. Women can still investigate their paternal surname line, but only indirectly by testing a brother, father, or paternal line male relative. None of this is a flaw in the technology. It's simply a reminder that your DNA reveals your clan is doing a lot of quiet simplifying in a single sentence, collapsing a fairly technical process into something that sounds like magic. None of that makes the discovery meaningless. If anything, it makes it more human. Think back to that man in Ontario, the one who opened his results and found strangers who shared his blood and his name. Whether his particular genetic thread runs straight back to a medieval Fraser chieftain, or joins the wider Fraser line through a great-grandfather who was formally adopted into the clan's protection 3 centuries ago, the result tells him something true either way. He belongs to a documented, traceable human network that has existed, in some form, for hundreds of years. That's not a myth manufactured for a marketing email. That's a real thread of continuity, even if it isn't the single unbroken bloodline the advertisement implied. The final twist in this story is the one most people miss entirely. The old Highland clans understood exactly what modern genetics is only now confirming, that a clan was never meant to be a closed bloodline in the first place. It was meant to be a shelter. Chiefs needed fighting men, farmers and loyal households more than they needed genetic purity, so they built alliances through marriage, land, and protection, then folded outsiders into the surname itself. The DNA evidence doesn't contradict that history. It quietly proves it, marker by marker, generation by generation. So if your surname is one of these 13, MacDonald, Campbell, Stewart, Bruce, Wallace, Fraser, Gordon, MacLeod, Douglas, Robertson, Murray, Ross, or Mackenzie, a test can genuinely tell you whether your Y chromosome sits inside the dominant cluster associated with your name, or whether your branch joined that story further along the way. Either answer connects you to something real. Neither answer is quite the fairy tale the advertisements promise. Before you close this video, go back to that man in Ontario, staring at his results. He didn't get proof of a single royal bloodline. He got something better. Evidence that his name was never just a label. It was a network of real people, real decisions, and real survival, written into his cells centuries before anyone thought to read it. If your surname is on this list, would you actually want to know which branch you're on, the original bloodline, or one absorbed along the way? Tell me in the comments, and tell me the name. If this changed how you think about your last name, there's another test hiding behind almost every Scottish surname that never made this list, and the story it tells might be even stranger. That one's coming next.